part one of this demonstration, we created a 3D structure, generated the mesh within the structure footprint, and then incorporated it into the main mesh for the domain. Now in this demonstration, part two, we will add the 3D structure to a simulation, run the simulation, and review the results. We're starting with a simulation that has been run previously on a mesh that did not include the bridge or the holes in the mesh for the bridge piers. Turn off the mesh. Here's the previous mesh. You can see we've got the bridge opening, but no holes for the piers. And for this mesh, we do have an existing solution, velocities, water surface elevations, etc. And we will use those as a starting point or an initial condition for running our next simulation with the bridge. But before we do that, let's go ahead and to preserve what we have now and to create a new simulation, we're going to right-click on the previous simulation and select Duplicate. So you can see now we've got a new simulation. I'm going to right-click on that. Let's go ahead and rename that to Q35000 CFS, and I'm just going to say with bridge. All right, so that's now a duplicate of this previous simulation. Now there's a couple elements, components I should say, within the simulation that we'll want to replace. The first one is the boundary condition component. The initial run with the previous mesh used a ramped discharge that ramped up from a lower discharge up to that 35,000. For this case, we want to start with that 35,000 as an initial condition, so we don't want to ramp the discharges. So we'll remove that for now. And then also, let me expand this out here, we want to now use the new bridge that has the holes in the mesh to represent the piers. So we'll remove that. The monitoring coverage is still the same and the materials coverage is still the same. So let's go up to the top here. We've got our new mesh with bridge that we want to go ahead and right-click that and apply that to the new simulation. And then for the boundary condition coverage, remember I said we used a ramped coverage previously. Now we're going to use this boundary condition coverage that has a constant 35,000 CFS as the inflow. So I'm going to click on apply there, and now that's applied to the simulation. Now we want to add our 3D structure. Now, to not get confused here, you do not want to add the 3D structure that's under the UGrid data. Look under the map coverage, and let's go down to this folder where we have put our bridges, and you'll see this is the coverage that ends in COV coverage is the footprint. We actually want to use this one here, the 3D structure main bridge. But do that by right-clicking, and the same way, we'll apply to the 35,000 CFS with bridge simulation. And if we scroll down, you'll see now that has been added to that simulation. So we now have 5 components in that simulation. Before we run the simulation, we want to generate an additional condition water surface elevation from our previous simulation. Now, since that simulation was run on a different mesh than what we're using in the simulation, we need to first go to that solution for the previous mesh. And what we're going to do is we're going to interpolate this water surface elevation data set to the new mesh. To do that, we'll right-click on that mesh, the demo mesh without bridge or with no bridge. You see this option to interpolate to. Select that. And then on the left, you see several options, several data sets we can interpolate. We want to interpolate the water surface elevation data set, and we want to interpolate that to the mesh with bridge. Okay, so that's selected. Click OK. And click OK. It says warning. It's just telling you it's interpolating or extrapolating a -999 value to anything outside of the data set range. All right, so if we look under the mesh with bridge, it now has a water surface elevation data set that has basically been interpolated from this mesh to this mesh on all of the mesh nodes. Okay, so now we'll use that as an initial condition for our simulation. Okay, good. So moving along, we need to now set the model control. And in this case, looking ahead, I'll save us some time. We do go into pressure flow in this simulation, and it does go a little unstable. And so what you'll see that when it tries to run the simulation, you'll get a red bar at the top, and it'll suggest a smaller time step. And so in this case, I've had to drop the time step down to 2 seconds. The end time, we're going to drop down to 40 hours, mainly because we're going to use a starting water surface elevation data set from that previous scenario that we just interpolated, previous simulation. And so that's going to save us some time from having to fill the mesh and reaching that condition. But it still takes a while for all the computations with pressure flow to work their way out and reach a stable solution. All right, now moving on, output again. We're only going to look at the simulation end output. Under advanced, go ahead and let's turn off that termination criteria. And again, we're just running steady state, so we don't have to have the unsteady selected. So we're good there. Let's go ahead and right click this. And I always like to do the save project, simulation, and run. So you can see it's now open the simulation run queue, and you can monitor these 5 tabs as the simulation runs. This one takes about 5 to 10 minutes, so I'm going to save your time and we'll go ahead and fast forward through this simulation. Okay, we have a completed solution. You can see from the green bars. If we go back to the command line prompt, if you look at the total simulation time on this was about 0.36 hours, so roughly 22 minutes. Now that we have a successful solution, we'll go ahead and load that solution. And you can see it's populated here under the new mesh with bridge. Let's go back to a full zoom here. And I'm going to go ahead and turn off the elements. Sometimes it makes it a little less busy. So we can look at velocity results. You can look at water depth results, water elevation if you wish. You can turn on flow vectors. All right, now what I'd like to do is to show you the 3D structure plots so we can see how the pressure flow is represented at the bridge. And just before we turn the bridge on, you can see that there's a change in color. So the water surface elevation beneath the bridge is lower. So that's what's happening. It's the pressure flow is forcing that flow to go under the bridge. But what I want to do first is, well, we can turn on a 3D structure. Then what I want to do next is under map data, go ahead and right click and let's create a new coverage. And specifically, we want to select the observation coverage. We can change the name or just leave it as observation. We'll do that. And make sure it's active. So if we scroll down here, observation is active. We want to create an arc. And we're going to draw an arc just starting somewhere upstream. We're going to go down through the bridge. Something like that. All right, not too long, but we just want to capture and see what's going on there. So now that we've added that arc, let's go ahead and right click on the 3D structure. And you'll see this option to review the 3D structure summary. All right, so it pops up this dialog. And if it had multiple bridges or multiple simulations, you'd see those here. We're just showing one here with the bridge. And then there's several different plots we can look at here. We don't have overtopping in this case, or I can show you that. It's just 0. So we can look at the total discharge through the bridge, so through the structure. You can see that at the end here, it should be just around, looks like almost 31,000 CFS. The roadway embankment is overtopping. So you can also, the total in this case is the same there. But again, if you have overtopping, you can show all 3 values. You can look at the water surface elevation up and downstream of the structure. Now, again, this is through the entire simulation, up to 40 hours. And then you can also display the weir crest on that if you need to. So very valuable plot. A couple other things here. You can look at the summary of the flow through the structure. And again, if you had overtopping, that would be displayed here. It shows the crest elevation. And then profile plot. We first have to select the coverage that we created. Observation coverage. Click that and go ahead and select the simulation. And so that's going to show the channel invert. It's going to show the water surface elevation for this simulation. And it's going to show the bridge. But we can also then review a cross-section plot through the bridge. Well, that does it for the 3D structure plots. And so that really, I guess that concludes part 2 of this demonstration. You'll follow similar steps in the next section of the exercise.